Okay, good afternoon to everybody. I'm going to present some information about especially focused on recirculation cooker hoods. Of course, some aspects are useful also for extracting hoods, that's for sure. So globally, of course, for hoods, three things are very important to bring together. It's design, because of course the product has to be liked by the customer. Function, and here especially the low noise level was detected from our side as very important for the customer. And here this is bringing, of course, interaction with the last point, which is air quality, because everything is linked together, for example, by the blower, by the pressure drop on the filters. So this is already the first point. It's a system, and we have to bring everything together in order to have a good function for the customer. For that reason, I'm not speaking only about charcoal filters, which of course is the most important element for recirculation hood, or maybe other filter types. So grease filtering as a first filter element, then I will speak about Odour filters. And last but not least, very important, and was already mentioned before, the catch rate, of course, is a very important factor, because things you don't catch won't reach the filters. And finally, then conclusion. So what about grease filters? Of course, in the market, the most used grease filters, at least in Europe, are the so-called mesh grease filters, normally built by expanded aluminum filters. So, of course, you have different handles, different frames, even different colors. But performance relevance, we have only in the exterior layers, especially on the entrance, and of course with the layers in between, because the number of layers, the sizes and all this are defining finally the performance for the grease capturing. I will not go into the details of the method, but just to remind you that finally it's done by weight measurement. That means it's measured the filter and the hood before and after the usage, that meaning applying oil and water vaporized below the hood. And then by finally measuring the weight increase of the filter and this calculation, you get the grease filtering efficiency. And this is giving finally the classes defined in the label. Astonishingly, even products with a very low level G can be found on the market, and this is quite strange because all the system behind will be then really contaminated with a lot of grease. So of course, intention should be always to have a filtering minimum at C, if not even better. What does it mean for the particles and for the numbers of particles and the mass fractions? I will come later on. But one important thing, and I think it's clear for all of us, at least, if the higher the amount of airflow is through the filter, the better is the grease separation. You see here the grease filtering efficiency over the particle size, and the blue arrow is indicating the rising amount of air. And you see the higher the amount of airflow is over this parameterized curves, you see the better the separation is. For example, if you go for very low speed, you even do not catch particles at 3 micrometers. But if you go for a reasonable high speed and the right filter element, you can even catch up to 85% of these particles. So for that reason, a good layout of the grease filter is important also for the whole system. And here some additional information about the particle size distribution, what was measured before entering into the filter under these test conditions. And you see, if you go for the volume or mass fraction, and then look for the border at about 2.5 microns. This is related with the famous PM 2.5. You see that above this, you still have more than 95% left to be captured by the filter, and only 5% are particle sizes below this 2.5 micrometers. On the other hand side, if you look for the number of particles, the amount of particles is the other way around. You have 95% of the particles which are have very low sizes. But of course, this cannot be captured by the grease filters. For the grease label, it's not important, but maybe for other aspects. This is the first filter. Then, of course, for recirculation hoods, the most important filter is the Odour filters. On the market, there are different options. In our portfolio, we have 3 options: a foam-based charcoal filter. We call it a waved charcoal filter with different layers. And finally, a regenerative filter, which is built by honeycombs. And these honeycombs are created from ceramic and charcoal. So they are molded in this way. And as you see below, of course, the lifetime of filters is different depending on the amount of charcoal. For example, for the starter set, in normal use, we count about 6 months. For this very good already Odour reduction filters, we count about 12 months. And if you see regenerative, of course you have to regenerate, then you have even a lifetime up to 10 years. Of course you have to regenerate, but the others you have to throw away after the lifetime because they cannot be regenerated. Concerning the Odour reduction rate, and here of course this is done with, I will come later on which method it was done. We use of course the MEK as tracer gas in order to evaluate these values. Meaning that with a waved filter we can have a very good Odour reduction, not as high with regenerative, and the lowest Odour reduction rate with the so-called starter set foam filters. An additional feature we have added to this wave filters is a biofunctional layer. Here we have the possibility to inactivate allergens that are captured by the filters, especially those who are contained within pollens, because this filter can retain 99% of the pollens that are captured, that are airborne. And this is an additional feature which is new on the market, and maybe for some customers it's interesting, especially for those who have in summer problems with pollens and so on. An additional function that is also not spread all over all filters is a so-called anti-fish function, or this anti-fish smell function, which was detected in the market as very important because we had claims. In the beginning we had only charcoal filters, but there have been claims, and finally it was found that this additional anti-fish function brings a very good result in the perception of our customers. Last but not least, some comments to the honeycomb filters. I already mentioned, of course, here you see the repetitions of these MEK measurements, and of course with the standard filters the performance is dropping down because they cannot be regenerated, but with the regenerative filters you nearly can keep the performance all over the life. Yeah? So this is very important. The inconvenient is, of course, you have to regenerate, and during regeneration the absorbed Odour is distributed again to the air, meaning that of course you have to have some ventilation during regeneration in the kitchen. So MEK is used as representing the volatile organic compounds, so that means the hydrocarbons. It is used because it's a liquid under ambient conditions, but can be vaporized and mixed with water, and this is very important to have a good dosing, an adequate dosing for the test. For that reason it is used, because to do it with a gas already is very difficult to use this as a tracer gas, at least from our understanding from the handling. Okay, test chamber, you already saw in the presentation before how it looks like. Here, just to remind you that as a reference point is always for recirculation, the situation, the concentration without Odour filter, and then the test with Odour filter. And by this calculation, the values that I've shown before can be measured within the appliance and with different filters. Concerning what I've already mentioned, the fish smell, we are using, and this is a not standardized test, and also this is not exactly done in this test chamber. We are using the so-called trimethylamine, and this is representing other Odour molecules containing amine components, because this can be very intense also in the smell. And this is an additional function that we have introduced to all our Odour filters. And this is giving a very good response concerning our customers. So this was concerning the filter technology. Now just some words concerning the catch rate. I mentioned before, catch rate is a very important part of a good working cooker, because if I don't catch in the first passing the emitted odors from the cooking process, of course they will be distributed all over the kitchen, and only in recirculation you can capture them again, but of course this is not efficient. So it's always the best to catch them in the first moment. I'm presenting here some very short extract of a study where we have been included, done by Passivhaus Institute and 3 other participants, but was led by Passivhaus Institute. You can see here some 5 example pictures done at power level 2 of this cooker hood, and out of a shot row of 50. This was a standard, so all these tests have been done with 50 shots in a time row in order to make the evaluation. And here we can already see that the catch rate, if you take it like this, is very unstable. That means there are a lot of fluctuations on it, and this is already giving a first hint that it's not easy to determine what is really a catch rate, and you will always need a certain time and then calculate in order to get it. Here you can see mean values, average values out of 40 shots. And on the left side, of course, this is when the hood is off, and then level 1, level 2, level 3, level 4. And what you can clearly see, of course, the more air is extracted, of course, the better is the average appearance in the capturing. For example, you could see on average, if you go for average value, on level 2, you could imagine that nearly already you have 100% captured. But this is the average value. And if we now go to the worst case situation, always out of 40 shots, you see in level 2, there are still moments where you don't catch 100%. Even in level 3, from time to time, you will not catch everything. And this is a clear indication that to get a catch rate of 100% needs some special conditions and needs a minimum airflow rate. What in this test was found, and it was independent of the cooker hood and cooker types, for worst case, we needed about 400 cubic meters per hour. And if for the average case, we needed about 300 cubic meters per hour to get a catch rate of 100%. Of course, with this visual method, not with tracer gases. In this study it was tried to do a test with tracer gas, but it was not, didn't give reasonable results, at least not within the time that was used in this study. And here, this is now our attempt. Hopefully you can see, this is a simulation. And we really have built up a thermal simulation with vapor. And with this, of course, by calculating and giving the mass fractions, you can really do a calculation of what is captured. Okay, it was not super parameterized, but here the two values is one is for the pod in the left side back and the other value is for the pod on the front side right. Of course, as I mentioned before, for 400 cubic meters, you have a catch rate of 100%, and this was clearly found also by our simulations. Perhaps it's not, but here on the right side for the so-called inclined hops, it's already different. We have, of course, 100% for the pod on the left side, on the back side, but not exactly, and this is also what you can see. I will start again on the simulation. From time to time, some vapor is escaping. And so what we think that maybe with simulation, we can even evaluate better than with tests where you have a lot of disturbances from the surrounding, at least for from our point of view, we may even see better distances between situations and different airflows and different designs. And this is very helpful for our development to get an indication what is the best situation. So, conclusions. I think I'm good in time, so I do not have to speed up too much. I mentioned for a grease filter, they are not exactly the most important for recirculation, but they are very important for the system in order to work correctly. Because they have to protect the charcoal filters, because if the charcoal filters would be contaminated with too much oil or grease, they will lose too fast, of course, their efficiency, which is very important. And of course, grease filters are somehow limited in the capturing of small particles. They work well if they look for the mass fraction, but of course they are limited for small particles. Odour filters itself are also not exactly made for small particles, but of course, depending on the fabric you use, of course, you can do something. But if you want to capture everything, the pressure drop would be so big that finally the performance of the hood is going down. So also here there are some limits. For that reason, we made this compromise to say, okay, we can capture pollen. For that, it's still a reasonable pressure drop, and have also, of course, good performance concerning odor and anti-fish smell. Of course, Odour filters you have to either to replace regularly or regenerate regularly if you have a regenerative lines, regenerative solutions. Odour filters, of course, there are also plasma filters on the market. The challenge for the plasma filters, from our perspective, is to respect the concentration of some, let's say, harmful gases that can be created by the plasma itself. So to respect the ozone values and the nitrogen oxide values, let's say, of course, it's possible, but to have a good odor reduction and on the same time to respect these values is, let's say, at least not easy. But this is just a comment for other options of odor filtering. And last but not least, of course, the catch rate. From our perspective, it's not easy with a measurement, and there are a lot of measurements all over the world discussed with different tracer gases and how to do it. What we found, it's very difficult to have really reliable catch rate value, and even if you want to see differences between different hoods, because finally, of course, if you go for a simple test, you will just see how many air you extract, and of course, the better the air extraction is, the better is the catch rate. But this cannot be the only parameter, and this is a challenge from my point of view for the future to define a good method for measurement, because as I shown before, from our perspective, simulation can already give very, very good hints about the real catch rate. And what we found in the simulations as well, that it depends a lot on the kitchen design and the ambient airflow, because depending on where the window is and how, if it is opened or not, or even depending on where the door is to the kitchen, this can change completely the airflow, especially for extracting goods. Perhaps not so much for recirculation. And now coming to the final conclusions, a little bit concerning the main title of the presentation, opportunities and challenges. The big positive points for recirculation hood, if we speak about all this energy efficient housing, it was mentioned before, the sealed housings that we have more and more. Of course, recirculation hoods do not have any loss of heated air extracted to the ambient. And of course, you have, if you want to have a hood like this, you do not have interactions with the ventilation planning and ventilation system in the housing, because there will be no interaction. If you want to go for extraction, it's getting much more complex. And what we already seen, that the charcoal filter and regenerative filter technologies have advanced a lot in the market, in the performance. Of course, there are limits. Of course, let's say, if you have the possibility of extract, of course, but if you go for recirculation hoods, there are meanwhile very, very good filters available on the market. On the other hand side, and here we are coming to the back side, we know that we have a great variety of performance, from up to even unuseless products on the market concerning charcoal filters, which may give a bad image to the charcoal filters due to these bad performances that some filters offer. And of course, you need to replace them with a certain frequency depending on how many times you use it, how intense you use it, or regenerate it. And of course, we have to admit that these filters are not capable to remove all particles. So, thank you very much for your attention.